So in the last lecture, I explained about what data flow modeling, type what models of architectures are there. In that, first one is data flow modeling, behavioral modeling, structural, and the mixed modeling. These are the different models of the architecture. So in the last lecture, I explained about what data flow modeling. So in that, we have to study what is data flow modeling. And next one is what are the operators of the data flow modeling. So now we will take an example to explain about the data flow modeling detail. Okay. So in the last lecture I explained about what data operators. There are 5 operators are there: arithmetic, comparison, concatenation, logical, and shift. These are the different operating types in the data flow modeling. So depends on that, we will study one example to understand the data flow model. So first one is a multiplexer. Multiplexer using logical operators. What are the logical operators? You know that is and, no, not, okay, XOR, XOR. These are the what logical operators. So what we are studying now, multiplexer using the logical operators, that is in data flow model. So now what I will do, I will take one example and explain. That example is what multiplexer by using the logical operators. So how to draw the multiplexer? How to show the multiplexer? See, here it is a mux. You are having what different inputs A, B, C, D. For the multiplexer, you are having many inputs and one output. Okay. For the demultiplexer, you are having one input and many outputs. That is the demultiplexer. It is multiplexer. We are having 4 inputs and one output and 2 selected lines, S0 and S1. These are the selection lines. Okay. So how to write the output here? Y is equal to A, B, C, D, right? Then how to write this means A, B, A, S0, D0, or D. It may be A, S0, S1, B, S0, S1, C, S0, S1, D, S0, S1. So what we are doing there? We are doing just addition for this output. Now I am writing only output. So for this you need 0, 0 for first thing, 0, 1 for second thing, 1, 0 for third input, 1, 1 for the fourth selection line. For this one 0, 0, 0, 1, 1, 0 and 1, 1 for S1 and S0. So we have to go this one in this manner input. Okay. Now I will write the program, then you will understand. So what we are doing now? We are taking an example of multiplexer with the logical operators. And for the multiplexer, you are having these are the inputs A, B, C, D are the inputs. Y is the output and 2 selection lines S0 and the S1. So for this, you are having A, B, C, D at the output with S0 and S1 are selection lines, but this is not written directly S0, S1. So for that, for one combination will be it is 0, 0. For second combination will be 0, 1. For third will be 1, 0. And last one will be 1, 1. Okay. The same manner we will do. See, if first I will start with the program. So to write the program in a VHDL, you are having 3 sections that I explained in last previous lectures only. What are that as? What are they? Library, first thing. Second is entity. Are you understanding, Vijaya? Reply me on chat box. See here, library, first thing. Second one is entity, and third thing is architecture. Okay, these are the three sections of the program. In the library, you are having two lines. To represent the library, you may use library and the use that I explained you. Next, in the entity, you are explaining what input and the output. In the architecture, you will explain the design. Okay. So first we'll go for one. First thing is library. So to write the program for the multiplexer, first we will write what? Library. How to write this? Library. Library. This is a type of standard library IEEE use. I told you that we are having two lines, library and the use. Use IEEE standard project 1164.all. So this here we are using the use library with the 1164.all. It is a particular library for the particular design. We are selecting here this library to write the example which one? Multiplexer using the logical operator. So this is about what? Library section. Next thing is that entity. In the entity, what we will do? We will write only inputs and the outputs. So entity. So this is the first section, entity. Mux. This entity name is Mux. 4:1 is. Okay. Entity name. Mux 4:1 is. So next we have to write what? Inputs and the outputs. 4. First one is that inputs. Na? What are the inputs here? Here A, B, C, D, S1 and S1. These are the 6 inputs for this multiplexer. So how to write this? A, B, C, D, S0 and S1. That all are in standard logic. And what is output here? This is what? Inputs, in standard logic. And what is output? While out standard logic. Okay. So this is the beginning of the entity. I am writing the entity name. Next I am writing what are the inputs and the outputs. Then it is an end of the entity. And what entity name is what? Multiplexer. MUX 4:1. Okay. Next one is architecture. Arc of. See what is this? It is a now next section is what? First one is library. Next is entity. Third one is architecture. So this is completely here with library and the entity. Now it's the architecture. Architecture arc of. See, it is architecture name. It is a entity name. Mux 4:1 is. Architecture, name of the architecture is arc I am taking here of which entity name is? Entity name is what? Multiplexer 4:1. So it will start with the begin. So what is input? Output wise, you have to represent output like this only. So for that, what is the first output? A. I told you, you have to go forward 0, 0. Keep it in mind. Next 0, 1, 1, 0, and 1, 1. So first one is output is what? A. Okay, same as A. Next, it is S naught. What is that? It is 0. Means what? This value is 0, no? So not of S naught. It is not of S1. So how to write this? A as it is. So what we are using here? Logical operators. Logical operators means and, or, and, not. So A, next is dot, means what? And. If it is plus, then it is or. So A and. Next thing is what? S naught. So for this, what I have in the selection line is 0, 0 first selection line. Next selection is what? 0, 1. So first we are considering this one. So A and not of S naught. Okay. Again it is and. Next is not of S1. Not of S1. Next, see, it is not of S1. Then it is a plus. Means what? It is all. Next thing is what? B. B as it is. Next, B and same thing now. B and not of S1, S naught. Not of S naught. Not of S naught. And it is not, it is 1, no? So it is directly S1. Okay, next, see what I did first. It is here and next it is what? Or. So I am writing here or. And after or B and not of S naught. Next, directly it is 1. So directly S1. So what is that? Next again or. So I will write here or. After or comes with what? C. C and. Okay. C and. What is this here? This selection line is 1. Means it is not. It should be directly S1. Then again and. Then it is 0 now. So not of. Sorry, this is 0. Not of S1. Again it is what? Or. So D as it is. Again it is and of. There is no not here because it is 1 and 1. So yes, no and S1. I think you understand this. So what we did here first? They started with what? Architecture. Architecture name. Next with the entity name. What is entity name here? Mux 4:1. So then I start with the begin. Then I am writing what? Output. Or the multiplexer output is multiplexer output. But it is in the logical format we are doing. So for first A, same thing. Just I explained it clearly. So it is a selection lines. We are having different selections. 0, 0, 1 selection. It may be 0, 1. It may be 1, 0 or otherwise 1, 1. These sections we have written here. Next what? End of the architecture. Did you understand this? What I am explaining now here? Multiplexer example with the help of the logical operators. It is having three sections. First one is library, second is entity, third is architecture. This only I am explaining you from past three lectures. Just it is having three sections. So library, entity, and the architecture. In the library, we will select the library which one is needed. In the entity, we are explaining what are the inputs and the outputs. In the architecture, we will tell about what design, how the design is. Okay. So if you know, if you understand this, then you can write this design automatically, because A and means what? And if we know this, then we can write this. If we know this, then we can draw this. Okay, so we can find out the design here. So if we know this, we can go for this. If we know this, we have to do this. Okay, so this is the example for multiplexer using the logical operators. So next we will go for what? Data flow modeling using the when statement. So when statement means what? First we have to study what are the syntax. If you know the syntax, then only you can write the program. So first we will study about the syntax. So what we study will data flow model. Data flow model using when statement. When statement. Okay. So there are the two forms. See what we are studying now? We are studying what data flow model using which statement? When statement. So for the when statement, you are having what? Two types of forms. One is simple form, next is selected when. So what is a simple form is that when else. First one is what? When else. So it is called as simple when. Are you getting? What I am telling you now is, for the when statement, we are having two forms. When else. That is when slash else. It is a simple when statement. Next one is what? When with select with select when. With select when, it is called as selected when. So now what I am telling you is that data flow model using the when statement, in this we are having two forms, simple when and selected when. In the simple when, you are having when slash else. In the when selected when with select when. These are the two forms. So we will go for first syntax. If you know the syntax, then only you are able to write the program. So first I will tell you the syntax for this statement. Okay. So what is the syntax means assignment. This syntax read assignment when condition else. When condition else. Again same thing. Assignment when condition else. Okay. So this is the syntax for the when else. Here assignment when condition, we are writing what condition here. If that condition is not satisfied, we will go for the else. Same thing. When you write some example, then only you will understand the syntax. Okay, there is some syntax for the when else. Now there is syntax for this. Okay, with select when. So what you are having for the syntax? With identifier when. With identifier select. With identifier select assignment when value assignment when value. This is the syntax for the what? This is the syntax for what? When there are two forms in the data flow model using the when statement. In that first statement is first type is what? Simple when, and next one is what? Selected when. When you are going for simple when, then it is when else. When you are going for a selected, then with select when. Okay, next here. So this is the syntax for this one. So assignment when condition else. Assignment when condition else. What is the condition? We are having some conditions. If I give some an example, then you will understand this syntax. Next is with selected when. Same with identifier select assignment when else. When value assignment when value. This is the syntax for these two forms. So now what I will do is I will take an example of multiplexer. Then I will explain you the when statement. Then you will understand easily. See here, multiplexer using the when statement. So this is the multiplexer. Just to explain about what? Before this one, multiplexer using the logical operators. Now we will study what? Multiplexer using the when statement. So we are having what? Four inputs A, B, C, D, and two selected lines S0 and the S1, and this is the output. So first one is what? When else. When else. Okay. So library IEEE. I told you while explaining previous only they are having three sections: library, entry, and the architecture. So now I am writing what first section: library. Library you are having for the library you are having two lines. One is library and next one is use. Library IEEE use IEEE standard logic 1164.org. Okay, so we'll go. This is the library section. Next, the entity section. In the entity section, what we will write? We will write what? Inputs and the outputs. Entity. So the name is what? Mux. And name of the entity is here is Mux is. So what we will do in the entity? We will write what? Input and the outputs. So what are the inputs here? A, B, C, D, S0 and S1 are the inputs. A, B, C, D, S0 and the S1 are the inputs. What are the inputs? By explaining the logical, I told you A, B, C, D, S0, S1 are the inputs. But here these A, B, C, D are in standard logic. In standard logic. Okay. For the selection, this is for the selection line S0 and the S1 are the selection lines. S0 and the S1 in standard logic vector. How many? See, how many selection lines are there? S0 and the S1. Highest one is 1, last one is 0. If it is S2, then highest is 2, last one is 0. So I am having here S1 not an S1. So what I will write? 1 down to 0. What is the meaning of this one? I am having three inputs A, B, C, D are in standard logic. I am having two selection lines SEL. Okay, SEL selection line. For that I am having what? Standard logic vector I am having. For this we are having what? Two selection lines. 1 and the 0. It will start with what? 1 and with the 0. If I am having 3, S0, S1, S2, S3 means I will write here 3 down to 0. But I am having only S0 and S1. So this 1 down to 0. Next one is output. So it is input, it is selection line. Next one is what? Output. For the multiplexer, they are having only one output. Why? Out standard logic. Why out standard logic? Okay. So this is the what entity? It is library. It is entity portion. In entity, just we are telling that which are the inputs, which are the outputs. So when we will start here the entity, then we have to end the entity here. End of multiplexer. So if I am taking it as 4:1 multiplexer name, the name is 4:1 multiplexer, then you have to end here 4:1 marks. Okay. What you are writing the name here, that only how to write. The name should be same. If you are using here capital M and you are using small m, then also there will come an error in the VHDL. So what you have to do? You have to use the same spelling, same caps. Okay. Case, upper case and lower case, whatever depends, same name should be there. So it is entity, mux is, it is an end of the mux. End of the entity. Next we will go for what? Which section? Architecture. In the architecture, what we will do? We will write what? Code. Once it's like design. The main design we will write in the architecture. It is a library. So where we have to take we have to take the what? Functions, operators. In library, what will be there in the library? In the library you are having procedures, you are having functions, you are having operators, you are having everything what you need for the design, everything will be there in the library. According to your need, you select your library. So what you select your library means according to your design. So first thing is library is over here. So to express the library, we are using two lines, library and the use. Then we'll come towards what? Entity. In just we are explaining only inputs and the outputs. It completes entity and entity module. Next one is what? Architecture. We are now at present, we will represent the whole design in the architecture. So how to write this? Architecture. The next lecture I will use different sketch pen, okay? Architecture. Marker I will take different. Architecture. So first is architecture. You have to write the architecture name here. The name should not be same for the entity and its architecture. So I may write it as mux 4:1. Otherwise, I may take different any mux 2. I can take any name I will take, but it should not be same as the entity. Okay, mux 2 of entity name. Entity name is what? Mux. Mux is. Okay, architecture mux 2 of mux is. So we start with what? Begin. While explaining in the previous class, I explained about what? All the syntaxes. Okay. So we start with what? Begin. With begin. So why is less? I told you while representing the output, you need to show like this only. Y is less than equal to. Okay. In architecture, if you want to represent the output, you have to show like this only. So y is less than equal to. Now I am writing about which program? When else. Okay. Not select. Only when else. It is simple. So y is less than equal to a. The answer is A here. See, while previously when I explained you what output. What will the output for the mux here? Y is equal to A, B, C, D plus plus plus. A is when S0 and S1 are what? 0, 0. Otherwise, B is when it is 0, 1. C is when it is 1, 0. D is when it is 1, 1. If I am taking here as 1, 0, automatically the what will be here? This C only. Because it is like this. If I am taking the 0, 0 selection lines, automatically the output will be A. Okay? This is the output of the multiplexer. Okay? While explaining what logical operators, I explained this. So what I am writing now? I am writing the multiplexer output, the design in the when else statement format. So when A will be when you are having selection line as 0, 0. When selection is equal to what? 0, 0. Selection is equal to 0, 0. Else. Understood here? When else. Y is less than equal to means Y is equal to output is output form. When selection line is 0, 0. Otherwise, it is B when selection is equal to what? 0, 1. Else 0, 1. Else C. Right now for B it is 0, 1. For C it is 1, 0. C when selection line is equal to what? 1, 0. Else see A रहेगा, it may be A, otherwise it may be B, otherwise it may be a C. If ABC is not there, you are having A, B, C and D as output. If you are having A, else you are having B, else you are having C. If three are not there, automatically it is D only. So else it will be D. End of the mux 2. Right? So this is what the program. How what I am writing here? Architecture mux 2 of mux is. It is architecture name. It is entity name. It is begin with output is equal to what? A when selection line is 0, 0. B when selection line is 0, 1. Else. C when it is 1, 0. You may write it as like this also. D when selection line is equal to 0, 0, 0, and 1, 1. Okay. Okay, you can write this also. Otherwise, directly you can write as C when selection line is 1, 0, else it will be automatically, there is no option, it will be D only. That is the end of the mux 2. This is the example of multiplexer with the help of the when else statement. I think you understand this. Project, do you have any doubts regarding this? If you are having any doubts, ask me on chat box. Just type on chat box. Okay? Any doubts? This is regarding about what? Data flow model using the when statement. When else. In the next lecture, we will study about what? When with select when. Okay? Any doubts? Reply me.